I'd like to clarify a little something about independence when you're looking at contingency tables. So the major events, the events basically are the person's major and gender. Those are the two events that we're looking at. Now, in those two are subcategories. If you take any one of those subcategories and do a bit of a test with it, you will determine whether a contingency table has independent events, in this case, major and gender, or whether it does not. So I've created two examples here to show you how this works. It does not matter which subcategory you choose to use to do your calculations with. In the first case, I'm going to use accounting and female. And the rule for independence, and there's a couple different ways of doing it. Page 176 of your textbook talks about the two possible ways. I think the easiest way is what they call the alternative way, which says the probability of A and F. Well, the probability of A and F is very easily found because all you need to do is take the value inside. And so I'll look here and you can see where it highlights probability A and F. This is the probability. Remember, probabilities in numerator is always what it is the number that you're using, and the denominator is the total. So the probability of A and F together is the cell here that represents the overlap. 40. There's 40 female accounting majors. So 40 out of 185 is the probability of A and F. The probability of this one, A times, this is the actual probability of the individual events. And the individual events, and notice when I did this, I put parentheses around the formulas. The first formula is probability of A. Well, the probability of counting comes from the total here, which is 85 out of 185. And the probability of F, which is female, comes from the 95 out of 185. And then when I calculate that, I get this. They are not the same, therefore they're not independent. Now, to prove this, that you could choose any one of these in here, I also did the probability of E and N. So I took economics and male. I first did economics and male, D divided by F, and I got an answer. And then I took the product of the probability of economic major, which is a 70 over 185, times the probability of a male, which is 90 out of 185. And I did this calculation and I got, again, different numbers. So I could say that these are not independent. So to prove what I'm doing, I decided to take another example with different numbers in here to see if independence, if the concept works. And it does, because if I take the same thing, A and F here, I am taking the accounting, female and accounting, divided by the grand total, which comes up to 0.225. And if I take them separately, just accounting majors, the probability of an accounting major is 90 out of 200 times the probability of a female major, which is 100 out of 200, and I get 0.225. They are independent. So gender and major are independent in this example. In this example, gender and major are not independent. I hope this clarifies this concept and what you have to do to get the answer. Thank you.